In this lesson, we're going to discuss polynomials. The word polynomial just means many terms. And we do have a standard form since we have a few terms in our expressions. We need to arrange the terms so that the term with the highest exponent goes first. The highest exponent goes first. Then we need to follow with the other terms with their exponents in decreasing order. Exponents in decreasing order. And the last term should be the constant, which remember, constant is just a number. Okay, so if we want to use this as an example, this expression, we want the first term to have the highest exponent. The exponent of this term is 5. The exponent of this term is 3. So the 5 was the largest, it goes first. Then you follow in decreasing order. So 5, we did not have a 4, so then 3. There's no 2, no 1. And then the last term should be our constant. And our constant in this case is the -5. So standard form. Now, parts of a polynomial. So parts of a polynomial. We have terms, coefficients, constants, a leading term, a leading coefficient, and the degree of the expression. And we need to be able to identify all of these things. So looking at example 1, okay, I would like for us to underline the terms. So how many terms does example 1 have? Well, it has 3. That's your first term, second term, and your third term. So I would like to say that terms are separated by addition and subtraction. So once you see a plus sign, that's the start of a new term. Or when you see a minus sign, it's the start of a new term. And terms are held together through multiplication and division. Like the pieces of this term, this is 4 times y raised to the 5th power. So that multiplication is holding the coefficient and the variable together. And then that leads us to the next word, which is your coefficients. So I'm going to highlight our coefficients. Coefficients are the numbers in front of the variable. So we have a 4 in front of the y, and then a +7 in front of the y. Always include the sign that's in front of the number because it belongs to that particular number. Okay, so we have 3 terms, 1, 2, 3. We've highlighted our coefficients. Now the next thing is our constant. And I would like to circle the constants in each example. Now, if our expressions are in standard form, the last term should be the constant. And in this case, we have -5. So that is our constant. Now, the last 3 parts of a polynomial, we're just going to go ahead and fill those in. So the leading term. Okay, so you can only determine the leading term when the expression is in standard form. Remember, in standard form, the term with the highest exponent goes first. So the leading term is the very first term in the expression. So 4y to the 5th power. Okay. Now the next thing they're asking us for is the leading coefficient. Well, the leading coefficient is just the coefficient of the leading term. And we've already highlighted the coefficient of the first term, and that was 4. And then the last the last thing we need to determine is the degree of the expression, and that is the highest exponent. And if you look at our expression, the largest exponent is 5, so the degree of the polynomial is 5. Okay, so a few things to talk about since we've worked through one example and talked about the different parts. Now, this polynomial has 3 terms. This is known as a trinomial. A few other polynomials with special names are the ones that have 2 terms. That's known as a binomial. And then expressions that only have 1 term is known as a monomial. So we have a monomial, which has 1 term, binomial has 2 terms, trinomial has 3 terms, and anything larger than that we will call a polynomial. Now moving on to the next example, we have this expression 5x squared minus 4x cubed plus 9x minus 6. So our first step is to put the expression in standard form, or put the polynomial in standard form. Okay? Standard form, you have to put the term with the highest exponent first. Looking for the term that has the highest exponent, this one has an exponent of 2. This one has an exponent of 3. If you just see an x or just a letter, the exponent is 1. And constants technically have an exponent of 0. The reason why is because anything raised to the 0 power is equal to 1. Okay? So the term that should go first is the negative 4x cubed plus 5x squared, because 3, 2, then 1, 9x. Then our constant should be last. So this is our polynomial in standard form. Now we're going to identify the number of terms. We have 1, 2, 3, 4. We have 4 terms. So since this has more than 3 terms, we'll just call it a polynomial. No special name for this one. All right, so that's our first 4 terms. Now let's highlight the coefficients. We have negative 4, 5, and 9. We wouldn't count 6 because there is no x, so that's considered our constant. Okay? And now let's circle the constant. So that is our negative 6. Okay, so the leading term, remember, it has to be in standard form. So we're not looking at the original. We're looking at the rearranged polynomial. So our leading term is negative 4x cubed. The leading coefficient is just the coefficient of the leading term, which is negative 4. And the degree is the exponent of that term, which in this case is 3. For the next example, we're going to do the exact same thing. We need to first make sure the expression or the polynomial is in standard form. And then we will identify all of the important parts. Okay, so I see, looking at all of our terms, which, by the way, well, we'll do that after. So looking at the number of terms, the highest exponent is m to the 4th power. So that should be our first term, so 6m to the 4th. Then we can do minus 3m cubed, because we're going in descending order. So next would be plus 9m squared. And then our degree 1s to the 1st power, that's negative 10m. And then our constant, plus 6. So now we have our polynomial in standard form, and we can now identify all of our parts. We have 1, 2, 3, 4, 5 terms. Okay. Now we need to highlight all of our coefficients. We have 6, negative 3, 9, and negative 10. And circle our constant. Our constant is 6. Okay. Now our leading term, after we rearrange the polynomial, was 6m to the 4th. So the leading coefficient of the leading term is 6. And the degree of this polynomial is 4 because the largest exponent in the polynomial was 4. So now let's talk about some polynomials that have more than one variable in a term, which is okay. You can have as many variables as the problem allows in each term or in any one term. If you look at this example, we have 2 terms. The plus sign is here, so that means there's a term in the front and a term behind it. All right. Now, if you notice in this term, I see an x and a y. Same thing here, x and a y. When we have terms like this, the only thing you need to really worry about is just making sure when you combine them, they also have the exact same exponents. Like, I cannot put these two together because this x is a square, but this x is not. Same thing with the y. It's a cube, it's y to the 3rd power, but this is y to the 1st power. So they're not the same, we cannot combine them. Now, this also comes up with your degree. So remember, the degree is the highest exponent of the polynomial. Okay? Now, if you have a term that has 2 or more than one variable, then you have to add their exponents in order to get the degree of that term. Okay? So just talking it through before we actually do the work. Okay? We can also use that to determine if our polynomial is in standard form. We want the highest degree to go first. If we add the 2 exponents together, this one is 5. And then remember, both of these are degree 1, so this will be a total of 2. So we do have it in descending order. There is no constant that we need to worry about. So we can call this one a binomial because it has 2 terms. And then let's also highlight our coefficients, just because that's what we've been doing. Okay, so our leading term, 6x squared y cubed. That's it, you just copy it down. The leading coefficient of the leading term is 6. And the degree, remember, if it has more than one variable, we need to add their exponents. So 2 plus 3 gave us 5. So the degree of this polynomial is degree 5. And then for this problem, we're going to do the exact same thing. I'm just going to go ahead and rearrange it. But let me check the degree of each term. So this will be 2, this will be 3, this is a 0, and this is 4. So since this one gave me 4 when I added their exponents, this should be my leading term. So I'm going to rewrite it. 3x squared, y squared. Then in descending order, go to this one, negative 3x squared y. After 3 is 2, plus 4xy. And then our constant goes last. Okay. So now that we have that in standard form, let's go ahead and finish this off. So we have 1, 2, 3, 4 terms. Our coefficients, 3, negative 3, and 4. And we do have a constant this time, so we'll go ahead and circle the negative 4. And then let's identify these 3 parts. So the leading term, after we rearranged it, was 3x squared y squared. The leading coefficient is just the coefficient of the leading term, which is 3. And the degree. Remember, to find the degree of a term, we have to add the exponents if there are more than one, or if there's more than one variable. So 2 plus 2 makes 4. So the degree of this polynomial is degree 4.